Um, for HW4, fitting non-dimensionalized data, so we have the horizontal cylinders, and the Nusselt numbers has been experimentally correlated to the Reynolds and Braddon number, which is like in this equation. We have C1, C2, C3, and then we have A, B, and C. We also have the Reynolds number as well as the Breton number, or like we can calculate those number. So the requirement of this experiment homework is to randomly choose 50 pairs of Reynolds and Prado number and calculate the Nusselt number. And then next, generate the synthetic data by multiplying each of the 50 calculated Nusselt numbers by the normal distributed random number with the standard deviation is 0.02 or like 2%, and with the average is 1. And next we will fit the synthetic data set to model above by minimizing the mean relative square error between the model and the synthetic data. So let's start it. New notebook. So said this is homework 4. First one, I will just import the numpy or like every functions that I will use. So from skippy, optimize, minimize. Okay. Then I have A equals 1/6, B is 9/16, C is 8/27, D is 2. So A is 1/6, B is 9/16, C is 8/27, and D is 2. Okay. Then C1 equals 0.6, C2 is 0.387, 0.6, C2 equals 0.387, C3 is 0.559, C3 equals 0.559. Okay. And for first, we will create choose 50 pairs of Reynolds and Prado number to calculate the Nusselt number. So we'll create a Reynolds number, like a random number to choose for Reynolds and Prado number. So equals to random state like 2 1 4 2. Then we have n is 50. Then we have Reynolds number. We will choose from range. We choose range space we choose from 10, like the Reynolds number is from 10 to -4 to 10. So this log space is like 10 power of something. So this is -4 to 10. Then we choose from this 50 pairs. So we choose, so we have n is 50 already, we set it. Then next is Prussia number equals log space. It's similar to that, but like from 0.1 to 10 to the 4. So we also have log space from -1 to 4, and then this is n. Okay, then and then we will calculate the Nusselt number, which is use this equation. So we have u equals to C1 plus C2 times Reynolds number power of A plus C2 times Reynolds number power of A divide by 1 plus, okay, A divide, let's have the parenthesis on this. This is the numerator, and this the below is like 1 plus the parenthesis C3 over Prado number, C3 over PR power of B, then now this power of C, and everything power of D. So we'll print our Nusselt number, like this is our Nusselt number. Okay, we'll print Reynolds number, Prado number, and Nusselt number. What? Why? Oh, I have this is okay. So this Presto number, I think like this a lot. Like I just print everything out. Okay. Yeah. This is the first requirement. The next one, generate synthetic data by multiplying each of 50 calculated Nusselt numbers by normally distributed random number with the average of 1 and standard deviation of 0.02. So we will create like another Nusselt number. We call it we can call it data. So just like real data. Okay. Just like real data equals to Nusselt number times random normal of point. So location is 1, scale is 002, then size equals to n, like 15, like 50, so n, so new real, can compare it with new, like they are different. This is our real, like the the Nusselt number with point, like with 2% error, and this is the like the normal, like our calculated one. Okay. The next one, the next is feed the synthetic data set to model both by minimizing the mean relative square error between the model and the synthetic data to determine the corresponding coefficients. So the next one is we will have we'll define another like a function such as define mean, so feed the synthetic data. So as define is at like minimize like mean square error. Okay, mean square error as this is a v, this as a, b, c, d, c1, c2, c3. Then we have Nusselt real. Oh, actually Nusselt. So this model. So I just like Nusselt model equals to. I just copy this down because it's similar. Have used a similar equation. Then we return it as what mean of new model, the minus new real divided by between the model and the synthetic data to determine the corresponding. So I will the difference between the model and the real one. So I will just divide by new real. Actually, then everything squared. I think this. Right. Okay. And is that correct? Minimum square error between. Okay. Oh, okay. So it has to be square first and then mean of those squared. So actually this. Then we have the result equals to minimize mean square error A, B, C, D, C1, C2, C3. No? This is real. Okay, so we have this is the result. Alright, this is our result. And let's try so like because we used ABC ABCD C1 C2 C3, so like it show like very exactly similar to our ABCD. Let's try print options precision for 6. So I hope it will print like and then we'll try to print A, B, C, D, C1, C2, and C3. Yeah, like this and this, then this. Okay. So this is our I think like this is everything. I will just run. Okay. I don't know why they don't print out everything, but like print like this like 6. It should be like 6 decimal after 5 decimal after this point. So but like I don't let me try like 4. No. Yeah, by the way, it just like that because of the decimal point, like number of decimal point after this, so it couldn't show the like the point 2 differences, the point 2 difference between the models, like the models and the real one. But like it's actually has the point like 2% difference, or like we can see in between like 0.1667 versus 0.1666666, etc. Something like this is like very, we can observe like the difference between them. So this everything of this homework. Thank you.